Hello to everybody who's joining this video. Now, today we have a lot of things about Cartesian coordinate system, which people gonna say, okay, what is this? I'm gonna use the knowledge of chemistry and say, okay, even though we're gonna use in physics a dot to come and go, you can say if the z exists, for example, or if a coordinate system exists, we're gonna have z coming out like chemistry. We're gonna have like a very bold vector like this. So we're gonna have vector z x y. Consider this as a 3D. We don't have to, but just let's consider that as a 3D. We're gonna have for each of them have one unit vector. Remember, the unit vector rule is of one unit vector, and we're gonna have x hat, y hat, and z hat according to Cartesian coordinate system rule, and they're gonna be perpendicular to each other. So you're gonna have 1 times 1, because let's say x times itself is gonna be 1, and then you have 1, 1 for y, and then 1, 1 for z. You're gonna get 1. That's pretty much easier to find out, okay, why if you add this up together. But here's also the thing, if you have like x and y, okay, actually I see what it is. Okay, so if you have x and y, y and z, because the dot product, I may make a mistake on drawing these. Let's say this is the coordinate system that we have. Let's forget about this one. Yeah, x, y, and z, because the dot product of x is gonna be, itself times each other, so it's gonna be giving us a 1, because it's just a unit vector that we need, and then it's gonna be 1. And dot product is gonna also be 1. Y is also gonna have 1, because we're gonna have just like the whatever y has times the y that we're gonna have, and then the cosine is gonna be 0, so cosine of 0 is 1, and if you have a 1 unit vector for y, it's gonna get 1 again. Over here, it's the same logic for 0, even though, it's the same logic for x, because x is gonna have 1. Z also have, because we go 1, 1, and then the cosine of 0, it's gonna give us a 1, and that's how we get 1 as a proof. Over here, though, it changes. Because we have x and y, and remember they are 90 degrees angle. For the dot product, we're gonna have 0. Because remember, cosine of 90 degrees is 0. No matter what we have for x and y, we're gonna get 0 still for that row. Now, after that, we're also gonna have z and y. Still the same thing, because we have a 90 degrees angle. Same thing for z and x. We're still gonna have a 0. So that 0 is gonna give us this whole rule of a dot product. Again, forget the numbers because I didn't receive our numbers. And I'm going to show you that in the thing. Because if I have 1 times 1, let's say that's 1, and then I have cosine of 0, since cosine of 0 is 1, we're going to get 1. But if I have 1, 1, and then we have cosine of 90 is 0, so we're going to get 0. This is how we can prove that, okay, why x times x and a cosine between them, because there's no angle, is going to give us a 1. Cosine of y is going to give it the same thing. Cosine of z hat is going to give it the same thing. And remember, dot product gives us a scalar, because scalar is a number. Dot product, if we have a vector, we're going to say, okay, vector A is this. We're going to give a vector sign, but scalar is a number. It doesn't have anything that we can use on it, so it's going to be scalar. So that's probably, hopefully, give you guys a very understanding of how to do dot product and have this huge theory in physics being proven right. And especially if you have x and y over here, just do x and y and see, give you the definition by the system and stuff like that of how we get that. And also another part, we know the perpendicular dot product, because I told you cosine of 90 is gonna always be 0, and cosine of 0 is 1 always. So that's how we can get the proof of these. And hopefully you guys understand. If you have any concerns, just let me know in the comments, and hopefully we can go over it together.